Here's a solution to 3 word problems that occur in the online homework for section 4.1. In this first problem, we're trying to express revenue as a function of quantity sold so that we can find out what number of things we have to sell in order to maximize our revenue. We know that revenue is given by price times the number of things that are sold. And but in order to turn this into a revenue function, we need that to be just using one variable. So instead of price times p times x, we need to rewrite this so that there's only one variable being used. So we usually do this with x, but you can do it differently if you have a different problem. In order to do that, I need to know what price is in terms of x. So this equation that's written as x equals stuff about price, we would need to solve for p so that it's written the other way around. If we do that, you're going to get p is negative 1/4 x minus 80. The way I'm doing that is subtracting 80 from both sides and then multiplying both sides by negative 1/4. So my revenue function then is negative 1/4 x minus 80 times x. And I can resolve some of these parentheses anyway. This is negative 1/4 x plus 20 times x. And you may ask yourself, should you multiply this out or use FOIL or whatever? We have seen in a lot of problems that it actually was better to have it in factored form. So I would always leave it in factored form unless you know you need it to be multiplied out. So right now I will leave it like that. So that's the answer to A. And you can see that it's given here. Now notice that the domain that I'm writing down here is really coming from these two individual pieces. We know that x, since it represents the number of things that are being manufactured and sold, that x has to be at least 0. The negative x doesn't make any sense. Also, if we're trying to sell something, we expect the price to also be greater than or equal to 0. So this first condition is already a condition about x, so that's good. But this second condition is about price, and so I need to turn that into something about x. I can do that by just coming back up here to this equation and asking myself, what are the extremes for this value of x? Notice that I'm given that the price needs to be between 0 and 20. And so I could just ask myself, what's the x when price is 0? And what's the x when price is 20? If you answer those two questions, you'll find out that the value of x has to be between 0 and 80. So that's where that comes from. It's not really part of this problem, but it is part of other problems in this unit. So the part B is really just making sure you understand what you just found. It asks what the revenue is if 16 units are sold. So 16 units is telling you the x value. Remember, x is how many you sell. So if they tell you that 16 are sold, that's telling you that x is 16. And so the question B is really just asking, what is the value of R of 16? Now part C is asking about maximizing revenue. This is because the R of x function, we drew a picture of it. We have numbers sold on the x-axis, and we have revenue on the y-axis. The revenue function, if we graphed it, is going to be a parabola. I can tell that because the formula here for R of x has a minus x squared in it. So a quadratic that has a negative number in front of the x squared term is going to be a downward concave parabola. So it's going to have a maximum value. And that's what part C and D are asking about. So in this approach on these slides, I did multiply out the revenue function, and then I just applied the formula negative b over 2a to find the x-coordinate of the vertex. And so that'll be negative 20 over negative 1/2, which is positive 40. And if you plug 40 in to the revenue function, you'll get $400 as the revenue, as the maximum revenue. So those are going to be your answers to part C. When I did this in class, I pointed out that you could actually work from the factored form because it's easy to tell from the factored form that revenue is going to be 0 when x equals 0. So in other words, when this factor is equal to 0, or when the other factor is equal to 0. So because we have two factors already written out, I know what the two numbers where those are going to be 0. And remember, the parabola is symmetric, and so if you know where the two x-intercepts of a parabola are, then you know the vertex is just halfway in between. So obviously that gives you the same answer, but it does give you a different way of getting it. All right, part D is just asking what price will lead to that maximum revenue, and so that's really just asking a question about this price-demand equation. We know that x equals 40 is the number we would like to sell in order to maximize our revenue, and so the question then is, what's the price in order to make x equal to 40? So we would just replace x with 40 in this equation, and then solve for p. And if we do that, we'll get p is $10. And then finally, the question is, what do we need to charge in order to make at least $300 in revenue? Remember, the revenue function, the outputs are revenue, and so this is going to give us an equation to solve. We want the revenue function output to be 300. So question E really comes down to solving this equation. If we were to multiply everything here by 4 and get our terms on the same side, this actually is something that can be factored. If you don't see how to factor it, then you can just use the quadratic formula. But if you do it, you'll get x equals 20 or x equals 60 as your answer. And from the demand equation, to get x equals 20, you'll need p equals 15. Again, we're talking about this equation up here. And to get x equals 60, you'll need p equals 5. So to find those two values, I'm doing exactly the same thing I did in part D. I'm finding what value of p gives me those values of x. And so the relevant cutoffs for making $300 are when you're charging $5 or charging $15. So because we know the parabola is shaped down, is concave downward, then we know that for any price between 5 and 15, the revenue is going to be above the $300 threshold.